Hello, in this video I'm going to provide an introduction to waves, including different types of waves, as well as how to calculate velocity, wavelength, frequency, or period of waves. First off, the content and language objectives. A content objective is I can distinguish between different types of waves. Language objective is I can write about the relationship between wavelength, frequency, period, and wave speed. So first off, there are two different types of waves that we're going to be discussing. Transverse waves, sometimes students call them wavy waves, or longitudinal waves, which are sometimes referred to as compression waves. First off, transverse waves. Transverse waves, again, sometimes students call them wavy waves. What you notice is as they move from left to right, it says source on the left-hand side, and then direction, it's pointing in light blue towards your eye. These waves move up and down. So they move perpendicular up and down as the wave travels from left to right. Longitudinal waves, on the other hand, are sometimes referred to as compression waves. They do not move up and down as they move from left to right. They just have zones in which they compress, or the waves are tightly squished together, in zones of rarefaction where those waves are further spread apart. And an example of a compression wave would be a sound wave. Anatomy of a wave, so a transverse wave, like the one that's shown here. There are many different vocabulary terms that you might have seen on the last slide as well. Crests are the tops of waves. It shows them as peaks here. Troughs are the bottoms of waves. Those are some terms you might already be familiar with. The term amplitude is shown. That's the height of a wave from the center point to the top or center point to the bottom. You see the term wavelength. Wavelength is the length of one wave from top to top or bottom to bottom, from one point in a wave to its recurring point. And period is the time from one crest or crest to trough, or trough to trough, excuse me. And so those are just some of the vocabulary terms that we'll talk about throughout this unit. Wavelength, it shows here, is the distance between waves. Frequency is the number of waves that you have per second. And wave speed is the length of each wave times the waves per second. So there is a relationship between wave speed, frequency, and wavelength. And so just to kind of show you how this makes sense, if you have 4 waves per second and each wave is 1 meter long, the wave speed is 4 meters per second. To give you an example problem here involving some sort of realistic numbers, it says if a sound wave has a frequency of 4,000 hertz, the unit for frequency, and a speed of 340 meters per second, that's the wave speed, what is its wavelength? And so what I would do in solving a wavelength, frequency, speed type of problem is to identify what you're given. We're given, again, frequency in red, measured in hertz, and we're given velocity, measured in meters per second. And we're asked to solve for wavelength in the bottom right-hand side of this triangle. And so wavelength is going to be velocity divided by frequency, or 340 divided by 4,000. Which gives us a wavelength of 0.085 meters. There's also a relationship between period and frequency. Period is the number of seconds per wave, and frequency is the number of waves per second. So as the picture on the bottom left shows, if you have a period that's 1/4 of a second, you have a frequency of 4, because it would take 4 seconds, or you'd have 4 waves per second if each wave is 1/4 of a second. And so these two different terms have an inverse relationship. And so the triangle on the right-hand side, bottom right of this picture, shows T for period in seconds and F, frequency, measured in hertz. 1 is at the top of this triangle. So 1 divided by one of these values is going to give you the answer to the other. And so if the frequency is 4, the period would be 1 divided by 4. Just an example problem. It says if a sound wave has a period of 8 seconds, what is its frequency in hertz? Again, what I would do is identify what variable you're given. And so if we're asked to solve for frequency in hertz, we're going to take 1 divided by our period, or 1 divided by 8. And so what would our frequency be? 0.125 hertz. That is the end of this video that summarizes different types of waves, as well as how to calculate wavelength, frequency, period, or wave velocity. If you have any questions about these concepts, please feel free to stop in during homework help hours or period 1A. Thank you very much. Have a great day.